The National Electrical Code does not specify a maximum number of current-carrying conductors allowed in a wireway. The 20% fill rule is generally applicable to raceways, not wireways. The inspector's concern likely revolves around heat dissipation within the wireway. Overheating conductors can pose a fire hazard, especially in poorly ventilated enclosures. To address these concerns, consider these approaches. Firstly, improve ventilation within the wireway by installing a fan to circulate air and dissipate heat. Secondly, use larger diameter conductors. Larger conductors have a greater surface area, facilitating better heat dissipation and reducing overall heat generation. Thirdly, ensure the wireway is situated in a location that minimizes exposure to external heat sources, helping maintain a cooler operating temperature. Fourthly, calculate the allowable ampacity of the conductors based on the ambient temperature and the number of current-carrying conductors. National Electrical Code Table 310.15. B2. Provides adjustment factors for ambient temperature, and Table 310.15. B3. Provides adjustment factors for the number of current-carrying conductors in a raceway or cable. These tables are used to direct the conductor ampacity to ensure that the conductor insulation temperature rating is not exceeded. For example, if you have 10 current-carrying conductors in a wireway and the ambient temperature is 30 degrees Celsius, the ampacity of the conductors must be derated by 50%. This means that if the conductor is rated for 90 amps, the allowable ampacity is now 45 amps. Fifthly, provide documentation demonstrating compliance with NEC standards for conductor ampacity and heat dissipation. This may include calculations, product specifications, and engineering assessments. Presenting this information to the inspector can help alleviate their concerns and demonstrate the safety of the installation. Sixthly, consider using conductors with higher temperature ratings. Conductors with higher temperature ratings can withstand higher operating temperatures without degrading, improving the overall safety margin. For instance, conductors rated for 90 degrees Celsius can handle more heat than those rated for 75 degrees Celsius. Seventhly, check the wireway manufacturer's specifications for conductor fill recommendations and heat dissipation capabilities. Manufacturers often provide guidelines for optimal performance and safety. Eighthly, ensure that all connections within the wireway are properly made and torqued to prevent loose connections, which can generate excessive heat. Loose connections increase resistance, leading to higher temperatures and potential failures. Ninthly, if the inspector remains unconvinced, seek clarification on the specific code sections they believe are being violated. A detailed discussion may reveal misunderstandings or differing interpretations of the code. Tenthly, as a last resort, if you are unable to resolve the issue with the inspector, you may need to contact the authority having jurisdiction, or OJ, for clarification or mediation. The AHJ has the final say in interpreting and enforcing the electrical code. Understanding conductor ampacity involves several factors. Firstly, conductor size determines the base ampacity of a conductor, which is the maximum current it can carry safely under specific conditions. Secondly, insulation type affects the temperature rating of the conductor, indicating the maximum temperature it can withstand without degradation. Thirdly, ambient temperature is the temperature of the surrounding environment, which can affect the conductor's ability to dissipate heat. Fourthly, number of current-carrying conductors. The more conductors bundled together, the more heat they generate, requiring derating. The National Electrical Code provides tables, such as Table 310.15. B16, which lists the allowable ampacities of conductors based on their size and insulation type, assuming specific conditions. These tables typically assume an ambient temperature of 30 degrees Celsius and no more than 3 current-carrying conductors in a raceway or cable. When these conditions are not met, derating factors must be applied. For example, consider a 12 American wire gauge copper conductor with THHN insulation, which has an ampacity of 30 amps under normal conditions. If the ambient temperature is higher than 30 degrees Celsius, or if there are more than 3 current-carrying conductors in the wireway, the ampacity must be reduced using adjustment factors from NEC Tables 310.15. B2. IN 310.15. 8.3. Always refer to the latest edition of the National Electrical Code for the most accurate and up-to-date information on conductor ampacity and derating requirements. Proper conductor sizing and derating are crucial for ensuring the safety and reliability of electrical systems. Failing to comply with these requirements can lead to overheating, insulation damage, and potentially electrical fires. In the context of wireways, the fill percentage limit typically applies to the cross-sectional area occupied by conductors, splices, and other components within the wireway. While the National Electrical Code does not explicitly state a maximum number of conductors, it does provide guidelines on fill percentages and spacing requirements to ensure adequate ventilation and heat dissipation. For example, the National Electrical Code specifies that the sum of the cross-sectional areas of all conductors in a wireway shall not exceed 75% of the interior cross-sectional area of the wireway. This requirement helps prevent overcrowding and ensures that conductors can dissipate heat effectively. In addition to fill percentage limits, the National Electrical Code also addresses the spacing and arrangement of conductors within wireways. Proper spacing between conductors helps improve ventilation and reduce the risk of overheating. The National Electrical Code may also require the use of barriers or dividers within wireways to separate conductors of different voltage levels or functions. When designing and installing wireway systems, it is essential to carefully consider the fill percentage limits, spacing requirements, and ventilation needs to ensure compliance with the National Electrical Code and to maintain the safety and reliability of the electrical system. Consulting with a qualified electrical engineer or inspector can help ensure that the wireway system meets all applicable requirements. Always refer to the latest edition of the National Electrical Code for the most accurate and up-to-date information on wireway installation and conductor fill requirements. The ampacity correction factors for ambient temperature are found in NEC Table 310.15. B2. This table provides adjustment factors based on the ambient temperature surrounding the conductors. These factors are used to reduce the allowable ampacity of the conductors when the ambient temperature exceeds 30 degrees Celsius or 86 degrees Fahrenheit. The ampacity adjustment factors for the number of current carrying conductors in a raceway or cable are found in NEC Table 310.15. B3. This table provides adjustment factors based on the number of current carrying conductors in the raceway or cable. These factors are used to reduce the allowable ampacity of the conductors when there are more than 3 current carrying conductors in the raceway or cable. The National Electrical Code definition of a current carrying conductor is a conductor that carries current under normal operating conditions. This includes phase conductors, neutral conductors that carry unbalanced current from a 3-wire system, and equipment grounding conductors when they carry fault current. Conductors that do not carry current under normal operating conditions, such as spare conductors or control conductors that only carry current intermittently, are not considered current-carrying conductors for the purposes of derating. Some inspectors might have local amendments or interpretations of the National Electrical Code that are more restrictive than the base code. It's always a good idea to check with the local AHJ to see if there are any local requirements that apply to your installation. Understanding the applicable electrical codes and standards is crucial for ensuring the safety and compliance of electrical installations. Consulting with qualified professionals and staying up to date on code changes can help avoid misunderstandings and ensure that installations meet all applicable requirements. In this case, clarifying the inspector's concerns, providing documentation, and exploring alternative solutions can help resolve the issue and ensure a safe and compliant installation. Also, the National Electrical Code Section 376 covers metal wireways. Article 376.23 covers the number of conductors in a wireway. The sum of the cross-sectional areas of all conductors at any cross-section of a wireway must not exceed 20% of the interior cross-sectional area of the wireway. Where all of the conductors contained in the wireway are evenly derated according to 310.15. B3. The sum of the cross-sectional areas of all conductors at any cross-section of the wireway must not exceed 40% of the interior cross-sectional area of the wireway.